Video number 54 in support of the 3D Experience CATIA generative shape design application. Uh, this particular playlist that I'm going to be discussing Helix in is devoted to the wireframe tab of this application. So Helix is a geometry that reminds you of a spring, uh, coil spring. And that is in fact the case. So if you select the wireframe tab in generative shape design, you have a pull-up menu and options of defining different things. We talked about splines in video 53, and now we are dealing with 54, which is Helix right here. Now, once you click on Helix, this dialog box opens up, and there is a whole different whack of different ways of creating the Helix. I'm going to go through them one by one. It's fairly straightforward. I'm following the presentation of this YouTuber, and his work is in CATIA V5, but I'm going to retrace the steps with CATIA with 3D Experience CATIA, which, incidentally, for those of you who don't know, it is not V5, but it's V6. Okay. All right, let's move on. So what I'm going to do is first I create a point. I can do that on the fly later on, but I'd rather do it right now. So let me create a point, maybe on the XY plane, and somewhere here. Dimensions don't matter. All right. Now we're going to go to the wireframe tab. We're already there. Helix. The dialog box opens up. And notice that there are different ways of defining the helix. Let's start with pitch and revolution. Pitch and revolution. Okay. So constant pitch and using this option. So let's make this thing the directions, a starting point. First of all, you need a starting point. That's why I created a point, or I could have done it on the fly by saying, okay, go make a point. I didn't do that. I created it right off the bat, it's right there. And axis is any direction. It can be the helix can be created in direction, for example, Z, or any direction tilted direction, or X or Y, etc. So I'm going to do it in direction Z. There we are. Notice that I said 1 millimeter pitch, 1 revolution. Let me make this thing 10 millimeter pitch so that you can see it better. Right there, you see that? 10 millimeter, 1 revolution. And let me make it actually 20 so that you can see it better. There, 20 millimeter, 1 revolution. Let's make this thing maybe 7 revolution. Right there, you can see that. And I'm going to say, okay, come back to that in a minute. So I started at this point in the direction Z that I selected with the pitch that I specified and the number of revolutions. Now let's go back. I don't need these planes, so I'm going to hide them, by the way. All right. So let's go back to the dialog box. Double click. What else can we do here? Now, we can go, for example, we can go clockwise or counterclockwise. Let me go ahead counterclockwise to see what happens. He goes the other way around. Okay. Starting point is this location, which right now it says 0. If I make this thing, for example, a different starting point in terms of starting angle, notice what happens. It starts there. Okay. Say okay. Right there. It started there. 15 degrees here. Okay. So that's what this thing is. All right. What else do we know? So this is a starting angle, 25 degrees actually, 25 degrees. Now let's say that we want this is a taper angle. This is a straight up, same, coil structure, although stacked on top of each other, but you can make it taper. Right now it's 0, so let me make this thing a non-zero taper angle. So this angle is essentially 15 degrees. We can go inward or we can go outward. See that? Inward or outward. All right. And that explains everything except that. Let me put this thing back to 0 actually. See why? 0. Good. Reverse direction, it's obvious. It goes, instead of going up, it goes down. No problem. Now, I haven't talked about profile yet. I will in a minute, but there is also this variable pitch. Variable pitch. And notice that variable pitch is, what's happening here is that, start from the top here, starting value 20, starting 20, you can see that, starting 20, and end value 1, end value is 1. So here is 20 millimeter pitch. Up here is 1 millimeter. If I change this thing, for example, to 7 millimeter, it's going to be like a 7 revolution. Okay, everything is the same. Uh, yeah, everything is the same, and pretty much that's it. Now, there is also a law here. See, there is also, when you use variable pitch, there's also a law. Right now, it is S shape. If I make this a constant, obviously, I'm going to go, if I say constant, I'm going to go back to where I was. Okay. Okay, but I want variable, click on it. And you can start, you can change that 20 and 7 from here. For example, if I want this thing to be maybe 14, starting 20, going up to 14, and this is a constant, this is a star. All right, that's good. Okay, so let's go ahead and do something else. Oh yeah, might as well do the profile here while I'm doing this. It is easier for me to delete the stuff to show you the profile thingy. Delete. All right. Now, we're going to click on notice that I deleted everything, including the point that I created out here. There's a reason I did that. Helix. Now, what did you say about 20? I need a sketch. Okay, so let me go ahead and do a sketch. On the vertical plane, I will sketch something. Maybe spline, exit. All right. Now, I click on the Helix icon. I want to select a profile. We'll worry about these things later on, put these numbers later on. Profile, and select this. And for the origin, starting point must be the bottom of the profile. You cannot select a starting point at some other location. Remember, I created the point there. I use it for starting a profile in part 1, but now I'm going to do this point. It has to be that. Okay. Now, let's make this thing a pitch of 20 and 20 revolutions. Let's see what happens. Once you create the profile, then essentially, well, we have to decide in what direction you wanna do that. Let's say Z. There we are. See that? It's following that. Now I can make this more. You can see stacks up on top of it. So the profile gives you the shape of this helix. Okay, the shape of this helix, starting at this point as it goes up the curve sketch. So let me make these things, instead of 29, we make it 8 so you can see it better. And let me go higher. There we go. You get the picture about profile. Okay. Yeah. Now remember, if you choose other direction, this may run into a problem. For example, let me try, if I tried X, it's going to go nuts. That doesn't make sense. Okay, cancel. That is fine. Okay, so now we're going to go look at the other options. So let me go ahead and hide this. Hide this. I'm going to hide that. I don't need it because I already showed you how the profile works. Let's do another helix. Helix. Now, we already did pitch and revolution. Let's do an height and pitch. Notice that the height and pitch, obviously when you say height and pitch, it's a constant pitch, right? Constant pitch. You don't have access to this side. So let's make it pitch of, I don't know, 17. Okay. Starting point, I don't have it because I deleted it. I can do it on the fly. Insert, maybe on a plane, this plane there. Direction Z. Oh, there we are. Uh, oh yeah. There is height and pitch, 17, pitch is 17 millimeter. The height is 19. So actually, let's make it, that doesn't make sense. Pitch is 17, height is 19. Obviously, you're not going to get more than one revolution. So let's make it 200, 200 preview. There we are. So you specified the height, the overall height, I said 200, and the pitch 17, so it just stacks on top of each other. Everything else is the same. Now, what if I did this? What if I did height and revolution? Did we cancel that? Let's do another one. The height and revolution. The height is 10. Revolution is 1. 1. So let's make this thing 10. 10 revolution over a 20 millimeter height. So, okay. Starting point, I don't have it, so let's go make it. Somewhere there. Access Z. Okay. And so the height is, let's make a height of 200. There we are. Everything else is the same. Yeah, so that's pretty much it. And good luck.